All right, 4.4, number 1, graphing functions. We want to graph the equation using slope-intercept form. We're given a linear equation here. We'll go ahead and make this full screen since we'll just be using the graphing tools. All right, so what we want to do is we want to start by graphing the y-intercept, and then we're going to use the slope, rise over run, to find the second point, and then it'll plot for us. So I'm going to zoom in, click this magnifying, make it a little bit bigger. Click the icon that you want. So depending on what type of equation, this time we have a linear equation, so I'm graphing the line. Be sure to read the graph and see how it's labeled. We're going to start at 8. Okay, so I'm going to go to the y-axis, go to the point 8, and click, make 1 point. And so now it's waiting for me to plot the second point. So to plot the second point, I'm going to count 8 units up and then 5 to the right since it's positive, up and right. All right, so I'm going to start on this point 8. I'm going to go up 8. That'll land me on 16. And we're going to go right 5. Okay, so it looks like each line is a half. I'm sorry, 2. Each line is 2. So in between the 2 lines gives me a half. All right, so pending that we've put the dots in the correct spot, it connects the lines and extends it. And then we just got to check it. Okay. All right, so we're good here. All right, question number 2. We want to use the graph of y equals 2 to the x power. And then we're going to use transformations to sketch the exponential function. We're going to determine the domain, range, also the y-intercept, and find the equation of the asymptote. All right, so let's talk about just basic exponential. Okay, so exponential graph hugs the x-axis and then curves up. All right, so usually with the technology, we will pick the type of graph and then we will tell it what kind of transformations and it will plot it for us. So the one that we're trying to graph is f of x equals 2 to the x minus 1 power. This minus 1 with the x is going to shift the graph to the right 1 unit. So we're going to have a horizontal shift. Other than that, there's no other transformations to the graph. The domain is still the same. So the domain is going to be all real numbers. The range still goes from 0 to infinity. There's no flip across the x-axis. So our range is still 0 to positive infinity. And the only thing that would change the range is if we got a horizontal shift up or down, like a plus D, something outside. We don't have that. And then since this is still our range, our asymptote is still considered 0. So if our graph gets shifted, so does our range and so does our asymptote. But since there's no shift, our horizontal asymptote, HA, is still going to be y equals 0. So those are some of the things they ask. We'll find the other ones as we get there. So here's our graph. This time we're going to click the exponential graph. I think if you just click anywhere, the graph will pop up. Now, make sure you have a base of 2, and then we'll input the correct transformation. So right now, if you scroll down, you have a base of 2 down here at the bottom, and then you have vertical shift, horizontal stretch, vertical stretch. Only thing we have is a horizontal shift. It's going to be right 1 unit. And then there's no reflection. So we just check that part. All right, part 2, what's the domain? The domain was not changed. It is still negative infinity to positive infinity. The range is still 0 to infinity. All right, part 4, the y-intercept, type in integer. All right, so normally we do an ordered pair, it says type in integer, so they don't want the ordered pair, otherwise they would say it. So the y-intercept, we just plug in a 0 for x. And this will give us 2 to the negative 1 power, which is 1/2. Okay. So just 1/2. All right, and then part 5, what is the equation of the horizontal asymptote? So that's still y equals 0. We didn't have a vertical shift. And we do know y equals 0 because it asks for an equation. It says type an equation. So we want something with an equal.